Hello and welcome back everyone. I'm Neil, and on today's episode we'll be using Yfinance library in Python to make our own features for our trading bot. And here I am on my Jupyter Notebook environment again, and I will start by importing our Yfinance and some other libraries for us to use during this video, and so that you can import these libraries like I am doing, and then you will be able to use them for your own trading bot. Here we imported the necessary libraries at the beginning, and here I will be using these tickers again. I'll be using multiple to be able to have a more realistic working logic, and I'll be using Microsoft and Google again, the classic tickers we have. And we will start by, of course, downloading all of the data we have. And here we go, download, and we'll use our tickers list. And for the period, we will enter 2 years again to have a great data. And here we will start by printing our data to show you guys once again that we can install. I'll be using Python environments. We are downloading data, and here we have the data for each stock, and these are grouped by the close, and under the close we have our tickers and high, and under the high we have our tickers. And here I'll be creating a new code section. So here, after getting our data, we will be getting the df data frame close data for each stock we have, and we will be using that. For here we can say just df close data, and using this we will be able to start our calculations. Here we will start by calculating the daily return. For the machine learning models, it's generally a lot more optimal to calculate and predict the change in the price, since the machine learning models will not be overtrained, memorized, or have other kinds of issues. It will be able to just predict the ratio, which will be always in one range, and it will not based on a stock, but it will be based on how the stock is performing that day. So for this one, we will start by, we can create a variable called percentage change, and here we can use this multiple ways. I will start by showing the way that's more easier for everyone to understand, and it will be more understandable instead of just using one function we have here. Then here where we will say shift. Oh, sorry. Oh, we already get the close data, so we don't need to do this, and we will be shifting. And then after this, we will divide our close data and then multiply it by 100. So once we print this, we should be able to get our percentage change. As you can see here, we have our percentage change, and for the first day, we don't have our percentage change, which is because we are trying to get the data from the day before, and we don't have that, since we're getting the data from close to close prices, and will be a lot better for our machine learning models to use. And for our machine learning models, it's generally a lot more optimal to predict the log return. This is because how they behave and how they work. So here I will also have another variable called log return, and for this one we will use a similar way, but instead of calculating the percentage change, we will be just using the log returns. And here I'm using NumPy, since NumPy is a great tool to use. And here we'll do the same thing we did, and we'll be shifting by 1, and once we print, it should work fine. And here, as you can see, here we have our log return, and this was percentage return. It will be a lot more easier for our machine learning models to be able to understand, and this will be a lot more simpler and easier to understand for people and humans, so we can see this and plot this and to understand our performance a lot better and easier. And now we will be continuing our tutorial by creating some features that we will be using. As a start, I will use a volatility feature, And this is especially important for us to be able to somewhat understand the risk of our predictions, not necessarily risk in a way, classic way, but we're seeing that how volatile our stocks are. And this is important because if a stock is really volatile, this will cause it to be change a lot, and this will be relatively a high risk, which would be a good thing if we have the right investment, but if it's the wrong investment, we will be losing a lot of money because of this, unfortunately. And here, as you can see, this is our volatility, and we will have different values. Like we can calculate the simple moving average, and for this one I will just create again we will be calculating the 50, but you can using the same function, just change the numbers. You can calculate it on your own and rolling. And here we will be using window 50 since we want to look at the averages. We will get the mean since this is just a simple moving average, and we can again do this. And the reason why I use tail here is because when we calculate using the 50 from the past, the first 50 items will not have data from the past, so it will be NaN, and I will show you guys how to clean that data as well, but I'll be using tail just to get the ones that are calculated properly. And as you can see, here is our simple moving averages. We will be getting the average of the last 50 prices. And finally, for the start, I will be calculating the EMA. This will be the exponential moving average. Here I will be starting by calculating our exponential moving average. This will also be like the simple moving average. However, this has an advantage that helps us focus more on the recent times, which will be more important. And using the comparison of SMA and EMA, we can see that how it's behaving towards the recent times, the stock, and using this we can get more information about our stocks again, and this will be useful for our machine learning models. As you can see, here's our EMA. However, I want to add something here. For this one, I will divide it by df close, and for this one again, I will divide it by df close. This is, I think, important, and for the reason for that is because we are normalizing again, and by normalizing, it will be a lot more easier for our machine learning models to understand and not overfit and memorize data and then make risky choices that will cause us a lot of money in the future. As you can see here, I have created the charts for us to see. We have the Apple prices here of the last approximately 2 years, and we have our EMA, and then it adapts fast, that's why it's called fast, and also the lower timeline. As you can see, it's showing our average of the price, but focusing more, weighting the recent times a lot more, comparing to SMA, which is behaving and weighing all of the timelines the same. And as you can see, we can plot our stocks and the data, and we can plot here our log return, and we can see how much our stocks are gaining. And as you can see here, it's lost a lot, and here gain a lot. This is also important. And just wanted to clarify something. I have removed our normalizations here, and the reason for that is because to plot it, we should not normalize it. However, while using for a machine learning model, I would recommend everyone to normalize their data so that they can get a more accurate prediction. And before we end our video, I wanted to show one last thing, and here we will create a variable called df volume, and for this one we can get our df volume data. This is useful because using the volume we can see how people are buying or selling, or what people are doing. If there's a lot of volume, this tells us that the stock has a lot of interest, it's arguably riskier, and volume can tell us stuff about direction and the movement, and especially for our machine learning models. So here I'll be creating a new feature called, let's say, volume SMA 20, and here we can create this by the same way we did. We can get our df volume, and then from our df volume we will be getting the rolling function, and then window 20, and then we will be getting the mean. This will show us the mean of the last 20 days of volume, and this is important because we can see the volume of the stock, particular stock at that day and the last 20 days average. However, this alone again is not useful, so we can normalize our data here. So we can get volume SMA 20 normalize, and this is important because we can just normalize this by dividing it with the DF volume, and this should give us the normalized version, which is again useful for our machine learning models to be able to understand how much volume that stock had at that specific date comparing to its average of the last 20 days. This is important because it's showing us the important days. As you can see here, this day every stock had an important day and it had up to 4 times more than the average, or 1/3 of the average. These days we will be using for our machine learning models to do more accurate predictions and similar stuff. Thank you for watching, everyone. Please don't forget to subscribe to my YouTube channel. Don't forget to like our video, and if you enjoyed it, subscribe. And if you want to watch my playlist where I will be creating a trading bot from scratch using my knowledge, and with the comments I will be improving it. If you wish to watch it, help me, and then learn yourself and experiment, please don't forget to subscribe. And thank you for watching. Have a great day.